Hi everyone and welcome back. In this video we're going to be talking about surface area basics. So if you can open up your foldable to that section, and what you should already have inside of there is your area of basic 2D shapes, square, rectangle, triangle, and circle, with the formula for finding the area of each along with one example. And the other thing that you should already have in this section is the definition of surface area. So next thing I'll get you to do is just grab a ruler, and right underneath where you left off with your 2D shape formulas for area, you can just draw a nice neat line. Okay, let's keep that contained and clear on your page, as it will be something that you will be referencing back to as you work through surface area of 3D shapes. So like I said, the other thing that you should have already in this section is a definition for surface area. And it should say something along the lines of the number of square units needed to cover a 3D object and furthermore the sum, okay, which means adding the sum of the areas of all the faces of an object. So that is what surface area is all about. So what we're really going to focus in on in this video is, like the section says, surface area basics. So how to calculate the surface area of some of our just most basic 3D objects. So the first one we're going to look at, we looked at in the previous unit actually, and that is a cube. So one cube. So I'm just going to, in my black pen here, sketch out a cube as perfect as I can, keeping in mind that it is freehand, so it's not going to be absolutely perfect, but I can mark it with these symbols to show that it is in fact a cube where all of the edges are the same length. Okay, and then the diagram indicates to us that the side length is 3 centimeters. The side length of one of these sides is 3 centimeters. And because it's a cube, we know that that means that every single edge is 3 centimeters. So to find the area of one of these faces, all we have to do is take our side length and square it. 3 squared, 3 times 3 is 9. That gives us the area of one face. But because the edges are the same, that means every single one of these faces is identical. How many of them do we have on the cube? We have 6 total. So this number can then be multiplied by 6. So that's for the surface area of a cube. So in this case, we'd go 6 times 9, because 3 squared is 9, and 6 times 9 is 54, and our units, centimeters squared, because we're talking about area. So we go to our original units and we just square them. So that takes care of the cube. So surface area for a cube, we just do 6 times the side length squared. Okay, next, let's look at a rectangular prism. So again, I'm going to just sketch this out. There's a rectangular face, front face, and then reaching backwards. There's my rectangular prism, and the diagram indicates to me that this length right here is 2 centimeters. This length right here is 4 centimeters, and this height right here is 1 centimeter. Okay, so to figure out the surface area of this shape, it's very similar to what we did here, where we just figured out what kind of faces we're dealing with. Okay, if we can figure out the area of each face and then just add it up, that's what surface area is. So you can always just kind of break it down and take it slow. And there is 3 pairs that we can separate this into. Okay, here we could separate it into, like, we could just times it by 6. Here we can still break it down. So the matching faces here are the front and back. Those 2 will match. So my front face right here is going to be matching to my back face here that you can't see. Next, I'd have my left side and right side. So left/right, those faces will be the same. So right here, this right face that you can see, plus the left face that you can't see tucked away there, those will be the same. And finally, my top and bottom will be the same. So this top face that you can see right here, and the bottom that's tucked away under there. So those are my groupings. Those are the faces that will be identical. So what that means is when I calculate one, I can just double it to cover both. So front and back, it is a rectangular face. So what's the formula for that? Length times width. So I've got 2 of them. So whatever I get for my length times my width there, I just have to make sure I times it by 2 to take care of front and back. Same thing, left side, right side, those are also rectangular, and there's 2 of them. So 2 times the length and the width for left and right. And finally, top and bottom, also rectangular. So 2 times the length and the width, length times width, for top and bottom. So now I can just start filling in these numbers. So the first one, 2 times, okay, what is my length and my width for the front and back face? Well, right here, my length, the diagram shows me, is 2 times my width. So that would be this distance right here. So while it's not labeled in the front, it is labeled at the back here, and we know that that parallel line right there will have the same measurement. So showing us back here, that's 1 centimeter, so this is also 1 centimeter. Okay, all of these parallel edges will have the same measurement. So 2 times 1 for the front and back face. Okay, next for my left and right side, so we're going to have 2, and then let's fill in the length and the width. So the length for this right side here that we can see, shows us right on the diagram, is 4, and then the width of it shows us right on the diagram that it's 1. So 4 times 1. And then finally, we have the 2 identical faces of top and bottom. So let's fill in the length and the width of those. So those are not labeled on the top here, but notice they're labeled on the bottom. And again, parallel edges, same measurements. So it's going to be 4 by 2. 4 times 2. Okay, so let's solve out each of those faces, and then the last step will be to double everything. So front and the back face, both of those individually are 2 centimeters squared. Left and the right, each of those is 4 centimeters squared. Top and bottom, each of those is 8 centimeters squared. So now we're just going to double each of those to take care of both front and back, left and right, top and bottom. So front and back all together, 4 centimeters squared. Left and right all together, 2 times 4, 8 centimeters squared. And top and bottom all together, 16 centimeters squared. So my grand total for surface area of all 6 of my faces, 4 plus 8 plus 16, grand total of 28. And my original units were centimeters, and I'm talking area, so centimeters squared is my final answer, 28 centimeters squared. So that's the rectangular prism. Okay, the last one that I'm going to show you today is the triangular prism. So this would be something like a tent diagram. So just sketch it out the best that you can. This one can be a little bit trickier to draw. So there's my rectangular prism. And remember, the height always has to be measured straight up 90 degrees from the base of the triangle. Oh, and here's the measurements it gives me. So it tells me that the base of this triangular face is 2 meters. It tells me that the height of the triangular face is also 2 meters. It tells me that this top edge is 3 meters. And finally, it tells me that this slanted edge right here is 2.24 meters. Okay, so let's begin breaking this down into identical faces. So first of all, we have the front and the back. So the front triangular face right here, and the back that's tucked away, we can't see it. So front slash back. Then we have the left side that we can see right here, and then the right side that would be tucked behind there. So plus the left and the right, those would be identical faces. And finally, the one lonely guy that we have that we can't see would be the bottom here. And in this case, there is no top, not for a triangular prism. So we would just have, oops, this isn't going to work. This isn't going to show up. A little bit darker yellow. So just simply plus the bottoms, which is a single. And you know, to be honest, sometimes they will have you include the bottom in the calculation, but if you're looking at, if this was a tent question, which is often what you'll actually see, you wouldn't calculate the bottom because, Oh, you might. I guess it's hard to say. You really just have to read the question carefully. If they don't want you to calculate the bottom, it will indicate it. Otherwise, you always should include it. So in this example, we're going to include it. Okay, but just watch for that, because not always will these type of questions need you to include the bottom, depending on what the context is. Okay, so we're going to break it down just like we did the last one. So the front and the back, so we have two of them. So whatever the area is of one, we're just going to have to double it to take care of both. Now for a triangle, the formula is base times height divided by 2. So that's what we're going to be doing to find the area of the front before we double it to also cover the back. For the left and the right, what shape are we dealing with here? It's just a rectangle. Okay, but we do have left and right, so we will have to double that. But rectangle is just length times width. And then finally, the bottom, well, there's only one, so we won't have to double it. So the bottom is just another rectangle. So again, length times width, different length times different width. So now let's start plugging in our values. So front and back, we will have to double it, whatever it comes out as. So base of my triangular front face is 2. Height is also 2. 2 times 2 divided by 2. Left and right, I do have 2 of those faces, so whatever comes out for the area of the left, I'll double it to take care of the right. So let's see here. So we have the length at the top right here, 3, times the width, the side right here, 2.24. And then finally, the lonely old bottom, the length runs parallel to the edge at the top here that's labeled 3, so that means that the length down at the bottom here is also 3. And the width of this rectangle at the bottom is the same as the base of the triangular face, so 3 times 2. Okay, so now we can get into actually solving these. So 2, and then 2 times 2 is 4. 4 divided by 2 is 2. So that would be the area of one of my triangular faces. Next one, 2, and then just going to pull out my calculator for this decimal. Length times width of my side piece here, 3 times 2.24. 6.72 is the area of one of my side pieces. And then last but not least, the area of my lonely old bottom, 3 times 2 is 6. Okay, so now let's double these up. So to take care of both the front and back triangular face, 2 times 2 is 4. To take care of both the left and the right, 2 times 6.72 is 13.44. And I don't need to double up the bottom because on a triangular prism there's only one bottom, so that just stays as 6. So now what I can do is 4 plus 13.44 plus 6. I'm just adding all of my matching faces together to get a grand total of 23.44. I'm not done yet because I need to include units. So original units were meters, and now I'm talking about area, so it's got to be meters squared. Okay guys, so that's all we're going to look at for today. Thank you so much for watching, and I will see you in the next one.